Okay, this video is going to go over homework 1.4, the first homework. I'm not going to go over the second one because I think that's just too much. But it is important for me to go over the first one in case anyone is still confused about how to go through these questions since they are a really integral part of this class. Right, so you can find that over here. If you haven't already, I suggest watching 1.4 kinematic equations. All right, and after that, then we go over the homework and try and see if you can do the homework yourself. Or just watch me do a few questions and then see if you can do the other questions yourself. Right? So let's click this. So you're going to do the homework, okay? We'll go over number one. So a car initially traveling east, right? So you have a car and initially traveling east, right? So you initially traveling east with a speed of 6 meters per second. So already you can see that this is a variable, right? We can assign this as our known because one thing we have to do right now is you have to find three knowns. So, well, what is 6 meters per second? What is that measuring? Well, besides context, a really easy way to just completely figure out, right? To figure out what you are solving for, or rather what you have, is just look at the units. We're gonna go to this cheat sheet right here. We're gonna go to the cheat sheet. And we see number one. So if you see this unit, you can assume it is a certain quantity. And so if you see meters per second, right? If you see meters per second, then you are dealing with a speed or velocity unit. All right, let's go into this. So here, so we know that this right here should be a speed or velocity unit. But we also see the context, right? A car initially traveling east with the speed of this. So we can basically say that is VI is equal to 6 meters per second. Is accelerated uniformly at 2 meters per second east. Right? So that's our acceleration. If you look at your cheat sheet, right? If you look at your cheat sheet, you should know that well, acceleration is measured in meters per second squared. East for 8 seconds. So time is 8 seconds, right? We measure time in seconds. This should not be a foreign concept to you guys. Right? We measure time in seconds. And the question wants us to find out, well, during this 8-second interval, well, the car travels a total distance of what? Right? What was the distance we traveled? So we're gonna go take a look at our reference table. Okay, we're gonna take a look at our reference table. Class materials, and you should have a physical copy of your reference table if you don't already have one. We're gonna go to all the way to the final page, right? And we see these formulas, right? We go to the last page on this reference table, and we see these three formulas. And here they are, right? All I did was copy them over. Now, which formula do we use? All right, which formula do we use? Because that is important. Right now in the problem, if you have your sheet on you, right? I'm just gonna write it down for you. We have VI. We know what VI is. VI is 6 meters per second. We know what A is. A is 2 meters per second squared. We know what time is. It's 8 seconds. and when we're solving for distance. Now here we're going to look for a formula that has everything we know, or rather everything we have and what we want to know. And so basically you're looking for a formula that has all of this. Let's look at the first one. Does it have VF? No. Right, we don't have VF here. We don't have VF here, so we can't use this formula here. Same thing with here. We don't know what VF is, and we aren't solving for VF, which means we can't use either of these formulas, which means we're only left with this singular formula here. So that's what we're going to use. And that's what we're going to use. All right, so moving it this way, going back to number 1. So now we're going to use that formula. We're going to use D is equal to VI D plus 1/2 AT squared. So we're just going to plug in everything. VI is 6, T is 8, plus 1/2 A, which is 2, T is which is 8. All right. So to simplify this, 6 times 8, 48. 8 squared, we do 8 squared first. Right? So that's 64. Moving down here, so we have D is equal to 48. We complete the rest of this part here. Again, if you didn't realize, this is multiplication, right? So 1/2 times 2 gives you 1, and then 1 times 64 gives you 64. D is equal to 112. And you'll see that none of the answers are here. But what you can do is you can convert this number to scientific notation. Right? We put a decimal here, we move it over 2 spaces. Because we moved it over 2 spaces, then our exponent for the power of 10 is 2. And so the answer here is C. All right? Now, let's move on to the second question, okay? Let's move on to the second question. Number 2. So an object initially at rest, okay? Initially at rest. Use a certain, use purple, I guess. An object initially at rest. And then that's a phrase, right? That's a phrase for something. If you go back to your cheat sheet, if you see phrasing, well, starting from rest means your initial velocity is 0. As well, like edit this to full stop. And that's basically something you can assume. And then think about it. Think about it, right? Think about it. So if an object is at rest, you're not moving. And if you're not moving, your initial velocity is going to be 0. And so we're going to write VI is equal to 0. We accelerate at 15 meters per second squared. Well, how do I know? Well, let me use a different color, right? Let me clarify what this is. So 15 meters per second squared accelerates at this number. So accelerates at 15 meters per second squared. Now there are a few ways to realize that this is your acceleration. First way is to realize, well, the context of the problem. Right? So it accelerates at this number. The other way is to look at your units. Meters per second squared. And if you go back to your cheat sheet, right? You'll see this unit, right? Units, if you see meters per second, you know that's acceleration. Acceleration is measured in meters per second squared. All right? So that's how we know. That's like the easiest way to know is by looking at the units of a number. So we continue doing this problem, we continue reading this problem actually, until it accelerates at this number, until it attains the speed of this. So you're going from rest to the secondary speed. Well, we know that since it says meters per second, if you look at your cheat sheet, well, that's your speed or velocity. It's measuring speed or velocity. And well, if you're going from one speed to another, you should realize that this is your final velocity. Right? You're going from an initial velocity of 0 to a final velocity of 30 meters per second. That makes sense, right? Meters per second, miles per hour. If you think about American units, miles per hour. And then if you switch to metric, it's meters per second. So the question continues, says, well, what distance does the object move during acceleration? And well, that's the question mark, right? So now we need to figure out what formulas to use, right? That's what we need to do right now. Make this a little bit larger. So we want a formula with all four of what we have. So let's look at this. Let's look at this. So let's look at the first formula, right? So do we have VF? Yes, we got VF. Do we have VI? Yep, we got VI. Do we have A? Yep, A. But do we have T? Or are we solving for T? No, we're solving for D. So we can't use this formula at all. Let's look at this one. Do we have D? Well, we're solving for D, so that's fine. Do we have VI? Sure. But do we have T, right? We don't have T, so we can't use this one either. And let's look at the bottom one. Well, do we have VF? Yep. VI? Yep. A? Yep. And we're solving for D. So we have everything here, so we're going to use this formula to solve for the equation. All right? So let's continue. Right, so the formula is VF squared is equal to VI squared plus 2AD. So 30 squared is equal to 0 plus 215D. 30 squared is 900. 0, 0. 2 times 15 gives you 30D. Divided by 30, because you want to get D by itself. 30 meters is equal to D. Alright? So that's your answer here. So the answer here is A. Okay. Alright. Moving on. Pause here is me trying to get the right windows. Apparently, okay, right here. Good. So number 3. Use green, sure. A race car starting from rest. And again, you see this. You basically see this phrasing, right? Starting from rest, so you know that your initial velocity is 0. And now we continue reading the problem. It accelerates uniformly at rate of this. Now, again, there are two ways to realize that this is your acceleration. The first way and the best way, right? The best way to realize this is your acceleration is by looking at the unit. It says meters per second squared. Because you see that unit there, you'll realize that this is acceleration. Again, according to your cheat sheet, meters per second squared measures acceleration. And the context in the problem also tells you accelerates. And so there are two ways that you can figure out this is your acceleration. One, by looking at what the unit is. Two, by reading the context of the problem. So now let's move on. Let's use brown actually, right? Because it's a new color. Keep things fresh. What is the car's speed after it has traveled 100 meters? So right here, you're trying to figure out, well, what is the car's speed, right? So after it has traveled that, so that's what you want to find out. Continue reading the problem, and it says after it has traveled 100 meters. And that's going to be your distance or displacement. How do you know? Well, you know distance is a measurement using meters. Right? Meters measures distance or displacement or length. So that's basically D. So D is question. Oh wait, I'm sorry. D is 100. Right. So D is 100 meters. So now we solve the problem. Again, we go to our formulas. Erase all of this. So let's look at the first one. VF, do we have it? Are we solving for it? Sure, we are. VI, we have VI, we have A, and well, we don't have T. Right, and again, we don't have T here, so we can't use either of these formulas. Let's look at the bottom one. Do we have VF? Yep. Do we have VI? Yep. Do we have A? Yep. Do we have D? Yep. Right, we're solving for VF, and we have everything else here. Let's move on. What do I use? Use brown. So we use the last one. Is VI squared plus 2AD. VF squared with 0 plus 2, 4.9, 100. Okay. 2 times 4.9 times 100, right? Because this 0 is nothing. So we're just left with this entire multiplication operation over here. So 2 times 4.9 gives you 9.8. 100 there. And now you're left with 9.8 times 100, which gives you 980. And now we're left with this, right? We want VF by itself, but VF here is squared. So we actually have to square root both sides. Right? We have to square root both sides, you get VF, and then you get something like 31.3 meters per second. That's your answer there. All right. Let's do the next one. Next one is up. Next one is up. All right, let's read this problem. Read the problem. A child riding a bicycle at 15 meters per second. Now this is a speed. Again, you're looking at the units, so this is like a speed number. Accelerates at -3 meters per second squared, right? For 1 second. So you can basically assume, right, based on the context of the problem, that the speed given here is your initial speed, right? A child's riding a bicycle at that speed. So that's basically your initial speed or initial velocity, right? So I should probably use purple because we want to stick with the same color scheme, right? It only makes sense that way. So purple 15 meters per second. Accelerates at -3 meters per second squared for 1 second. So that's green, right? That's green. The time is 1 second, right? So we measure time in seconds, so that's that. Again, we measure acceleration in meters per second squared, right? And we also can tell from the context of the problem. And we want to know what the child's speed is at the end of this all. So we want to know what VF is. By now, hopefully you're all like adept at just figuring out your knowns. But let's do this one more time. Let's just do this one last time. Let's look at these formulas. Do we have VF or are we solving for it? Yeah, we're solving for it. Do we have VI? Yep. Do we have A? Yes. Do we have T? Yep. We do. All right. So we're gonna use the top formula. That formula over there. So VF is equal to VI plus AT. Right. So VF is equal to 15 plus -3, 1, 15 minus 3, and gives you 12 meters per second. So it's going to be A. It's going to be A. Right. A rocket initially at rest. Rocket initially at rest. Again, that tells you something. That's a certain phrasing, right? Your initial velocity is 0, right? You're not moving. You're at rest. On the ground, lifts vertically with a constant acceleration of this number. So again, there are two ways. Well, you can tell from the context clue, right? Acceleration, or you can just tell from the units. So the meters per second squared is your acceleration. 0.0 times 10 to the 1 meters per second squared. And then how long will it take? That's a certain phrasing again. If you don't know what that phrasing kind of means, well, you can just look at your cheat sheet, right? Look at the questions phrasing, right? How long will something take, or how long, or something, right? It's just blank there. So that's gonna be your time. We're gonna find. We want to know what time, how long it takes to get to that height. And then you see this other number here. Let's say you didn't know what altitude meant. Altitude means like your height. But let's look at the units, right? It says meters. We measure distance or displacement in meters. And so D is 1.85 times 10 to the 4. 1.8 times 10 to the 4 meters. So now I want to pick a formula to use. I want to pick a formula to use now. And hopefully you're doing this yourself, right? Hopefully, if you're not actually copying my answers, maybe you're paying attention. Maybe you want to do this yourself. Because I'm just gonna say it, right? At this point, I don't want to keep bringing that like formula window over. I just want to move on. So the formula I'm going to use is D is equal to VIT plus 1/2 AT squared. Right? It has everything we need. We have D, we have VI, we're solving for T, we have A, and we're solving for T. So 1.85 times 10 to the 4 is equal to 0T plus 1/2 2 times 10 to the 1 T squared. Sure, maybe you guys can just use a calculator, put it in its expanded form. But I think that leaving it in scientific notation is easier. We'll solve it in scientific notation. 0 times t gives you 0. 1/2 times this number gives you 1 times 10 to the 1 t squared. Okay. So let's simplify this, bring this down. Let's get rid of the 0. Well, 1 times 10 to the 1 is just literally just 10 to the 1, right? It's multiplying by itself. And so now we divide by 10 to the 1 on both sides. So 1.85 times 10 to the 4 divided by 10 to the 1. When you're dividing powers of 10, you actually subtract their exponents, right? So you're going to do 10 to the 4 minus 1. So you're going to do 1.85 times 10 to the 3 is equal to t squared. We're going to square root this number. When you plug this into a calculator, you're going to get 43 seconds is equal to t. But you realize that your answer choices are in scientific notation. So to convert this number to scientific notation, we're going to do this, put a decimal there, move a decimal over one space, 4.3 times 10 to the 1 because you moved it over one space. So the answer here is B. All right. Hopefully that wasn't blinding because I used like light green. I'll never use that ever again. But let's move on. All right, let's move on. Number 6. Number 6. Right. Closer to the end. A skater increases her speed uniformly from this number, right, to another number over here. And there's a certain type of phrasing if you couldn't guess from the context of the problem. If you're increasing your speed from one number to another, right? So let's go here. Let's look at a phrasing. Let's look at the third one. Increases / decreases its speed from number to number. Well, if you have these two numbers, then the first number is your initial, the second is your final velocity. Right? It only makes sense. It makes sense. We know that we're going from one speed to another, so we're going from initial to final. Right, so let's see. Initial, so speed is 2 meters per second. VI is 2 meters per second. And your final velocity is 7 meters per second. Let's continue reading the problem. Over a distance of 6 meters. Right, we can say we know that it's distance because of the unit, it's meters, as well as we know that our velocities are velocities because they're meters per second. And then the problem says was the magnitude of acceleration is what? Right, so let's again, if you want to pause, see if you can figure out the formula, go ahead. Otherwise, I'm going to move on. The formula you're going to use is VF squared is equal to VI squared plus 2AD. Has all the variables we need, right? It has VF, VI. We're solving for A, and we have D. I'm going to plug in everything now. 2A, E, 6, 49, 4, plus 12A. Well, what the hell was that? 5, let's go to 12A. Divided by 12 because that's a multiplication there, right? I'm going to do the opposite. So A is 3.8 meters per second squared. Okay? And that's that. Do number 7 now. Number 7. A car increases its speed from this number to another number, right? So you're increasing your speed from one number to another. Well, then one's your initial velocity, and the other is your final velocity, right? VF is final. And we know its speed or velocity because it's meters per second. It says time is 4 seconds. T is 4 seconds. The average acceleration of my car is now what? VF is equal to VI plus AT. 20. So now we're going to use that. Again, we're using this because that's everything we need. Right? We're solving A for A, and well, we have everything we need. That VI is 9.6 plus A 4, 9.6. This gets you 11.2. 4A over here, divided by 4A on both sides. And we get A is equal to 2. Well, it's B or C. I'm trying to figure it out right now. Well, it's probably, yeah. So A is equal to 2.8 meters per second squared. Right? Now number 8. In a race, a runner traveled 24 meters. So since it says meters, we know that's your distance or displacement. In addition to the context, right? In addition to the context, we know that it's displacement or distance. So now I keep reading the problem. It says seconds, right? So we know that's time. So time is 4 seconds. It says that we accelerated from rest, right? So if you accelerate from rest, you see from rest, it means, well, your initial velocity is 0. It doesn't matter that it says accelerated here. To accelerate from rest, which means that our starting speed was 0. And the magnitude of her acceleration is what? Right? I don't want to use this color. I'm just going to use another color real quick. So we're going to use D is equal to VIT plus 1/2 AT squared. Why? Because we have everything we need, right? We have VI, we have T, and we're solving for A, and we have T. So 24 is equal to 0. The entire thing is 0. Anything multiplied by 0 is 0. T squared, so you're doing 4 squared here. So we're going to simplify this. 0 is gone. 4 squared is 16. Right? Simplify it even more. 1/2 times 16 gives you 8A Then we're going to divide 8 on both sides. Divide 8 on both sides. And now we have 3 meters per second squared. All right, that's our answer. And now, do number 9. We're going to do number 9 now. So, car traveling west. Again, this is important. Car traveling west. But let's deal with that later. Car traveling west decreases its speed from 30 meters per second to 4 meters per second. So when you're decreasing your speed from one speed to another, well, you know one is initial, one is your final velocity, right? So my initial velocity here is 30 meters per second, and my final velocity is 4 meters per second. Continue on, it says 2 seconds, so we know that's our time. Car's average acceleration is what? Okay. So the best formula we're going to use for this is VF is equal to VI plus AT. So 4 is equal to 30 plus A2. Let's simplify this. Minus 30. So this is negative 26 is equal to 2A. Divided by 2A. A is equal to negative 13 meters per second squared. Now we need a direction, right? And then, like I've said time and time again, is that your negative direction means opposite direction of your positive. Right? It's the opposite direction. Since we're treating our positive direction as west here, right? Because we didn't care at first place, because the car's traveling west. And basically what I did was when I wrote my velocities, I wrote them as positive. So basically I was treating west as positive here. And if I'm treating west as positive and we get a negative answer, well, that negative answer means you're traveling in the opposite direction of your positive. So the answer is C. The answer is C. This is really important. There's another way to solve this, right? Because again, you could have taken your west direction as negative in the first place. So you could have underlined west, and then your speed would be 30, and then your final would be 4. And you could have done this. You could have done VI is equal to negative 30 meters per second. And you could have done VF is equal to negative 4 meters per second because it's going west in 2 seconds. And so your car's average acceleration is what? And what is your car's average acceleration? And you would have done the same exact formula. So negative 4 is equal to negative 30 plus A2. So plus 30 plus 30. So 26 is equal to 2A. It's divided by 2 on both sides. 13 meters per second squared. And now since this is positive, I'm treating positive as east now, because I treated west as negative here. And well, I'm going to choose C again. Again, the most important thing to remember here, guys, is that your negative direction is your opposite direction. All right? It's your opposite direction. Doesn't matter if you treat west as positive or east as positive, as long as you're consistent with your frame of reference. And you realize that your negative direction is your opposite direction. All right? Cool.